Okay, just in general, if you have, for example, x to the fifth times x squared, you add your exponents together. So that would be 5 plus 2, and that give us x to the seventh. If you have x to a power over x to a power, they're the same variable. Well, what you do is you subtract the smaller exponent from the larger one. So you got 7 minus 2 is 5, and you're going to have x to the fifth where your larger exponent was. Larger exponent's on top. So we'll have x to the fifth. And where your other x to the power was, you just simply put a placeholder of 1. And x to the fifth over 1 is x to the fifth. Now if I have x to the third over x to the fifth, we still got x to a power over x to a power. You subtract the smaller exponent from the larger one. So we got 5 minus 3, which is 2. And we'll have x to the second power where our larger exponent was, which was on the bottom. And then we put a placeholder of 1 in the other position. If we have a negative exponent, here I got x to the negative 5. We don't like negative exponents. Our first step is to immediately get rid of them. And how we get rid of them is I'll take this x to the negative 5 and move it up on top. When you move anything opposite where it's at in a fraction, the sign of the exponent changes. So it goes from a x to the negative 5 to an x to the positive 5. And since there's nothing left down here anymore, you put a placeholder of 1, which gives us x to the fifth. If I have x to the negative 7, remember what I said. You need to move it opposite where it's at in a fraction. Well, this isn't in fraction form, but I can put it in fraction form by putting it over 1. And again, how we get rid of negative exponents is you take the part with the negative exponent opposite where it's at in a fraction. So we'll take the x to the negative 7 down below, becomes x to the positive 7, and there's nothing left up on top, so we put a placeholder of 1. And if we have a exponent raised to another exponent, you multiply the exponents together. So this will be x to the 2 times 7, or x to the 14th. And if you got multiple items inside of a parentheses, and they're connected by either multiplication or division, and you're raising the entire parentheses to a power, then you can take everything inside of that power. So you can take the x squared to the third power and the y to the third power. So I got x squared to the third power, and I got y to the third power. Now remember, when you're raising one exponent to another exponent, you multiply them together. So that's going to give us x to the 6 over y to the third. Now recognize that that is okay to do. But if I had a problem look like this, x plus y to the third, I said everything inside your parentheses has to be either multiplication or division. Here we got an addition. So I cannot take the x to the third power and the y to the third power. That one we just have to multiply everything out. Okay, let me clean off my tablet here. Now that we've reviewed some of those. And we got this one. We got 3x to the third, y to the negative 1 over z to the negative 2. Raise the third power. And then y to the third over z squared. Always you can think of your order of operations. Please excuse my dear Aunt Sally. Please do what's inside the parentheses. Well, inside this parentheses, something jumps out at me right away. We got negative exponents. We don't like those. So I'm going to take the y to the negative 1 down below, and I'll take the z to the negative 2 and move it up on top. So we're going to have 3x to the third. Remember, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So the z to the negative 2 becomes z to the positive 2. The y to the negative 1 becomes y to the positive 1. And all the rest of this carries down. Please, I'm still doing what's inside the parentheses. Now, when you got a fraction, usually you do what's up on top, and then you do what's on the bottom, and then you handle the fraction. There's nothing to do on top, there's nothing to do on the bottom. In this parentheses, there's nothing I can simplify. So please, excuse exponents. I got third power in here, I got first power, but they're just applied to a single variable, so those don't really apply. But here I got third power. And notice that everything inside of your parentheses is either multiplication or division. When that's the case, you can take everything inside of that power. So, we'll have 3 to the third, x to the third, z squared to the third, over y to the first to the third. And I'll keep the parentheses there because that parentheses indicates that it's multiplied by y to the third over z squared. Okay, well, 3 to the third is 27. When you raise one exponent to another exponent, you multiply them together. 3 times 3 is 9, so I got x to the 9th. And z, 2 times 3 is 6, so we got z to the 6th, over y, 1 times 3 is 3, so we got y to the third. Okay, that was the exponents. Please excuse my dear multiplication division. Well, I can do a little bit of canceling if I wanted to, but I'm going to go ahead and multiply these together. So, I got 27, x to the 9th, y to the third, z to the 6th. Notice when I multiply them together, if they're different variables, all I do is put them next to each other. And down here, I'm going to have y to the third over z squared. Well, notice that they both have a y to the third, so those automatically cancel. And here we have z to a power over z to a power. And remember what I said. If you got, I used x's, but same idea. If these are both the same variable, both the z to a power over z to a power, you subtract a smaller exponent from a larger one. 6 minus 2 is 4. And we're going to have z to the fourth where our larger exponent was. So we'll have z to the fourth up on top, because that's where our larger exponent was. And this disappears, and there's nothing left down below, so we put a placeholder of 1, which simply gives us 27, x to the 9th, z to the 4th. And that would be our answer.